Both source code and protocols are challenging to design. The use of refactorings is one way to assist designers build correct designs. A refactoring is a predefined transformation of something that preserves certain desirable properties. Now, a source code refactoring transforms source code while preserving compilability and program functionality. Source code refactorings were made popular by Fowler and the Eclipse integrated development environment. Rather than refactoring source code, we refactor protocols and interactions in multi-agent systems, while preserving agent interoperation. An interaction is a new architectural construct that combines a protocol on the bottom, a set of agents on the top, each of which enacts the roles of the protocol, and a set of interceptor chains which connect each agent to the protocol. An interceptor chain is a list of interceptors. Interceptors are the primary mechanism that enable interaction refactoring. Our library contains 30 interaction refactorings shown here. They are grouped into 3 types. Agent Designer Independence, or ADI refactorings, change the agent's implementation and the top end of the interceptor chains. Designer Collaboration, DC refactorings, change agent interceptors within a single interceptor chain. And Protocol Designer Independence, PDI refactorings, change the protocol and the bottom end of the interceptor chains. As an example, let's assume Alice and Bob have agents that interoperate with each other using a protocol called Pay. Pay is a very simple protocol between 2 roles, the payer and the payee, consisting of 2 messages. First, the payer promises to make a payment to payee, and then, at some later point in time, actually transfers the promised payment. Now assume Alice and Bob want to change their interaction to be faster and more secure. They ask Paul, a protocol designer, for help. Paul meets with Alice and Bob to understand the details of the current interaction and the requirements for the new interaction. At this meeting, Paul learns neither Alice nor Bob have time or budget to change or test new agent implementations. Paul will have to support the new requirements without changing the existing agents. Paul seems to have a very difficult task. But Paul also learns both Alice and Bob's existing implementations use our interaction architecture. Paul proposes a checking account from Global Bank to solve both the transfer speed and security concerns. Alice, Bob, and Global Bank will now interoperate using the Pay via Check protocol shown here. At design time, Paul writes the following code to transform interactions from protocol Pay to protocol Pay via Check. To eliminate any changes to agent implementations, Paul selects a list of interaction refactorings to transfer Pay to Pay via Check. These refactorings generate the interceptor chain's contents. The first refactoring adds a new bank role enacted by Global Bank. The second refactoring renames the promise message to choose message. The third refactoring opens the Global Bank checking account when the protocol is initialized. The last refactoring transforms the payment message to deposit funds in the checking account, send Bob an electronic check, then Bob redeems the check at Global Bank to receive payment. Finally, we serialize the interaction to a file that will be read at runtime. We implemented our system using the Jade Agent platform. Interceptor chains are implemented as chain agents. Agents always talk to their chain agents, and the chain agents talk to each other. At runtime, we use the following files. The .ser files are the serialized object files containing the interaction and interceptor chains created at design time. The .config files give each agent control over the protocols and roles they will agree to enact. The .shell files are the test scripts that configure and execute the various interactions that we'll see. Here is the config file for Alice. The first 2 parameters of each line are the protocol and role Alice will agree to enact. The remaining parameters are the name of the serialized interaction file and role for the interceptor chain implementation. Alice agrees to enact the payer role for 4 different protocols. Now we launch the Jade runtime with our agents. Switching to the Jade sniffer, we demonstrate Alice and Bob using the Pay via Check protocols. We have demonstrated the following points. We have a library of predefined interaction refactorings. We have Java classes to automatically refactor an interaction. We assert that all refactorings, with a few notable exceptions, preserve agent interoperability, and we are working on a proof of that. Our predefined refactorings simplify the design time process of evolving multi-agent interactions, and our Jade-based implementation executes the interceptors at runtime.